Due to the fact that the shaft used the Precision Directional Drilling System, DDS, the fresh air shaft had an offset of only 72 centimeters, and the exhaust air shaft only 14 centimeters, resulting in a world record for precision. Because the vertical shaft number 3 of the Xueshan Tunnel is located within the quartzite section of the Silong Sandstone Formation, the rock mass are highly fractured, with abundant underground water that always flows out the excavation surface, making construction very difficult and leaving it hard to maintain work quality. Therefore, after review and evaluation, it was decided to use the water-stopping grouting method to reduce water seepage into the shaft, and with the assistance of a forced water pumping and drainage system to ensure the progress and quality of work on the shaft. Therefore, in the mid-section of the Xueshan Tunnel, with a depth of 250 meters at the ventilation shaft number 2, two work faces were added on the northbound tube heading toward Pingling End and Tocheng End. These were used to help reduce construction time merely from the northern and southern portals. The work faces added through the ventilation shaft number 2 could only be accessed by a 250-meter vertical hole, meaning all rock debris, tools, supplies, and personnel had to travel up and down a vertical hoist. Working in such a closed environment is both dangerous and difficult. The ventilation shaft number 2 was completed in November 1999. After that, additional work faces on the northbound tube used the shaft as an access was adopted. During the initial stage, all large pieces of equipment had to be disassembled before being sent down the shaft and then reassembled down below. The grade of the Xueshan Tunnel inclines from the Pingling End to the north toward the Tocheng End in the south. As a result, all water from construction naturally flows toward the Tocheng End in the south. Consequently, it required a forced pumping system to pump the water out after a sanitary treatment in a collection well, and used a turbine to lift the water 250 meters up the vertical shaft for disposal. Since the work face on the northbound tube was opened in May 2000, it encountered several cave-ins due to water inundating the tunnel section through weak geological formations. On November 14, 2001, there was an 80 cubic meter volume of rock cave-in on the northbound tube near Tocheng End, and a large amount of flooding, reaching 82 liters per second, was recorded. The flooding came up too suddenly, leaving the pumping machines unable to handle the inundation. The resulting flood extended 200 meters into the tunnel, with the area of flooding about 3,150 cubic meters, and with the deepest water level 2.7 meters. Large effort needed to be done to resume the excavation, which included pumping out the water and performing waterproofing grouting in the rock mass. The additional work face at ventilation shaft number 2 provided the access to allow the main tunnel and pilot tunnel on the Xueshan Tunnel to achieve the goal of early completion. This included the completion excavation of 3,023 meters on the northbound tube of the main tunnel, excavating 1,321 meters on the pilot tunnel, and completing 1,110 meters work face on the top heading of the southbound tube of the main tunnel. Treatment of special geology and weak rock formations. On the excavation adjacent to the southern portal, the rock mass of the tunnel section mainly located in the quartzite of the Silong Sandstone Formation, which has the capability to hold large amounts of water, and with many faults and broken rock zones throughout. Therefore, tunnel roof cave-ins are quite often encountered when excavating, due to the adverse rock mass condition and large quantity of high-pressure water in the rocks. To reduce the time needed for handling drilling and grouting works. Moreover, the results on the ground treatment were all within a reasonably controlled scope, resulting in a great assistance for passing through areas with inferior geological conditions. Linking up the tunnels. For the 4 additional excavation work faces using drilling and blasting method of the Xueshan Tunnel, including the southbound and northbound tube from North Portal, and the 2 additional work faces connected by the ventilation shaft number 2, including the northbound tube toward Pingling End and toward Tocheng End. The geological conditions at these sections were relatively good, and the excavation work progressed well and faster than expected. The pilot tunnel was completed in October 2003. The northbound tube was completed in March 2004. The southbound tube's TBM excavation met up with the D&B excavation from the North Portal in September 2004, marking the linking of all tunnels. Mechanical and safety facilities. The Shreshan Tunnel uses two one-way tubes, with rescue support through the pilot tunnel. Continued delays. This was mainly due to the extremely hard quartzite of Silong Sandstone Formation and the abundant high-pressure underground water encountered in this brittle and fractured quartzite rock mass. After 14 years of struggle, adverse geological problems were conquered one by one. During construction, 13 workers lost their lives, leaving the engineers to endure great pain and pressure. In the midst of these heartless attacks and lessons, they attained many invaluable experiences. As work is completed on the Shreshan Tunnel, let us pay our respects to all the workers who contributed to its completion and look ahead to that brighter future it brings.